All right, I'm going to go over exam 3. The way I'm going to do that here. All right, here we go. What for a position the distribution corresponds to a z equal to -1. All right, with these, you're going to have your tables. The tables are located inside the back of the book, or you can also find them inside of MindTap towards the end. Let me sort of pop over here and I'll show you what I'm talking about. All right, they are the statistical tables. Just as an FYI, there are several tables in there. There is the one called the unit normal table. This is what we usually call just the Z table. Then there is a T as in Tom and an F as in Frank, depending on which test we're using. In this one, we are using doing Z-scores. The formula for a Z-score can be found on page 124, and that formula is just going to be, if I can make a bit of a Word document here. And again, this is chapter 5. This is just the review here. It is going to be a Z-score is going to be equal to X minus M divided by the standard deviation. All right, let's put X minus M in parentheses. The reason I'm saying to do that is because sometimes if you don't, your calculator, depending on what you have, maybe be the wrong number because it's not set up properly. Right? This is the formula we're going to use over and over again. All right, so let's go back to the exam. All right, what position in the distribution corresponds to a z of -1? With a z-score of -1, that means that you fall. What's most important when you're talking about z-scores is it will, if you tell me you made a 55 on the exam, I don't know if that's a good thing or a bad thing. What a z-score does is it allows us to make comparisons. And it what we call normalizes everything or sets everything kind of like at the middle. And then you can figure out, okay, are you above the average, which is the middle, or below the average? And then how far above the average are you? Because remember, standard deviation is just put the distance between everyone and like the average. And I think the example I used back in Canvas when I was first doing this was talking about we have a neighborhood, we have all these kids that live around this one school, and we're trying to figure out where to put the next school. And the best thing to do is to center that school so that on average, the distance between each student and that school is roughly about the same, right? So that's the general concept of standard deviation. There's a long formula. Remember the sum of squares, all of that to get to it. By now you should be, we've done entirely too much of calculating the z-scores. So, and the standard deviation. So this is the next chapter. In order to get that, you have to completely understand how to do the standard deviations. So if you don't, go back and watch the videos I've previously shown. All right, so this exam is using the formula from 124, page 124. A z is equal to x minus mu. We're basically going to use that formula over and over along with the table. So with number 1, if you are below by -1, this means you're not 1 point below the average. You are below the mean by a distance equal to 1 standard deviation. All right. Answer is C. Number 2, for a population, mu equals to 70. All right. And standard deviation equal to 8. What is the z-score? Corresponding to x equals 82. Let's plug that into our formula. So we're trying to figure out what is the z if we have 82, which is our x, minus the mu, that's 70 right there. Let's put that in parentheses. And so 82 minus 70 is going to be equal to here, 12. And then we divide that by our standard deviation of 8. When we do that, we find out that 12 divided by 8, and here it makes a big difference. When you set these up, it's going to be equal to 1.5. So remember the formula is x minus mu, okay? The reason you want to keep that is because if you reverse the 2, you might end up in the other direction because there's a difference between plus 1.5 and minus 1.5. So the answer to number 2 is going to be A. The z-score means that this person scored on average here 1.5 above the average. And if you notice this, I could figure out what they scored by simply taking, if they scored 1.5 above the standard deviation, I could take 1.5 times 8, then add that to that 70, kind of like when we're doing the confidence intervals, and find out that the number is 82. All right, number 3. For a population with a standard deviation of 6, what is the z-score corresponding to a score that's 12 points above the mean? All right? Sounds difficult, but it's not, because if you kind of think about it, we sort of did that, but before we had a score that was 12 points above the mean, but the standard deviation was 8. In this one, the standard deviation is 6. So let's go back and figure out what it's asking us. It wants us to calculate the z. All right? We already know that the score is 12 points above the mean, so we know the number has to be a positive, right? We can't rule out anything yet, right? But I do know that the difference between x minus the average is equal to 12, right? Because I'm 12 points above. The second information I have is I have the standard deviation here. So if I just divide that by 6, I get plus 2, all right? So plus 2 standard deviations above the mean here. And the only difference between number 3 and number 2 is number 2 had a standard deviation of 8. Number 3 has a standard deviation of 6. All right. Number 4, for a population with mu equal to 100, right? So I know that on average, the population average was 100. I know also that the standard deviation, or the average distance, everybody's about 20 points from the mean. It's asking me, what score did somebody have to get in order to be 0.75 standard deviations below the mean, right? That gives me some info already. And what I'm talking about here, I can try to come in here and graph it, because I like to use the shapes a lot. All right, using this. All right, so I'm going to use this over and over again. I know that whatever I am doing, I'm going to end up 0.75 below. Hold on 1 second, sorry. All right, so this one here, I know I'm going to be to the left of 100, so my score can't be 115, because 115 is actually above the score. All right, so if I just wanted to reason it out, I'm looking for what's the x that is going to get me to 0.75. I can shove, I hate to say shove, but I can put everything back into the problem, because before, remember, I'm using the same formula. Z is equal to, so I know that negative 0.75 is equal to some number, which is what I'm looking for, minus 100. And the rest of the formula just says divide it by the 20. Right, the math is going to look kind of weird on here, only because, remember, this is a negative 20. I have a negative 20 on the right on the bottom, so in order to get rid of it, I can multiply both sides by that 20. I think I said negative 20 before, just ignore me. So if I take 0.75 times 20, I'm going to multiply the left side by 20. I'm going to end up here with negative 15 is going to be equal to, and if I multiply the right side by 20, those 20s cancel out. So I'm left with x minus 100. Here, if I take my x to one side and I take the 100 over, I'm going to have minus 15 plus 100, which is going to give me an x of 85. What that means is the person who scored 85 on this exam, if the average was 100 and the standard deviation was 20, they scored below the mean, not a full standard deviation, only 3/4 or 0.75. And that makes sense, because if you kind of think about it, if I took 3/4 of 20, right, that would give me my error, and then I subtracted that from 100, I get the same number. So the answer here is A. All right, number 5. On an exam, my mu now is going to be equal to 52. Right, so on average, everybody got a 52, and I scored 56. Right, I don't know how great that is yet. Which value of the standard deviation would give you the highest points in the class distribution? All right, so it's asking me which of these standard deviations is the best. All right, so it's basically asking me, what's the relationship with standard deviation? All right, do I want a high standard deviation or a low standard deviation? Well, if I scored above the mean, the one that's going to give me the best score here is going to be the lowest standard deviation, right? And so if you weren't really quite sure how to start with this one, you could have substituted or came in here and basically just sort of put the practice problems in, right? So you could have come in here and said, okay, z is equal to the difference between 56, my x minus mu, 5, 6 minus 52, right? And remember, the standard deviation is in the denominator, right? So the bigger the denominator is, like this number is divided by 1,000,000, then this z-score is going to be really, really small. But if this denominator is like a very, very small number, then like a 1, then z is going to be relatively small. And so the problem was asking me, it wanted to find the highest position, right? So in order for z to be as big as possible, the number on the right side has to be divided by something really small, which is why I immediately went to the 2. But if I wasn't quite sure, I could have plugged in an 8 here, right? And just substitute the numbers in and figured out, okay, when I do that, my z here is going to be equal to 56 minus the 52 divided by 8 gives me 0.5. All right, what if my standard deviation had been 2? So let me just sort of take this off here and go 2. So now I have 4 divided by 2. And you notice with a bigger spread or standard deviation, I would have had been more further off to the right than 2 standard deviations above the mean. So again, when I say I made a 56 on an exam, that doesn't really tell you anything. What you need to know is, where do I score in relationship to the mean? How far on average am I from it? Am I 1 standard deviation, 2, etc.? All right, so again, number 6 here, we're using the same formula. The answer is going to be, 5, the answer is going to be 2. All right, a population, let's go to number 6. Population has a score of mu equals 80, right? So it tells me my mu is equal to 80. In the population, a score of 86 tells me that 86 is 2 standard deviations. My z is equal to plus 2, right? Can you kind of already see this? See the 86 minus the 80, that gives me 6. And then my z is a 2. So what number will go into 6 2 times? The answer there is going to be 3, all right? Because what am I looking for? I'm looking for what's the standard deviation. So if I plug these in, I'm going to have 2 is equal to 86 minus 80 divided by 2. I'm sorry, divided by x. All right, if I cross multiply both sides by x, I end up with 2x on my left is equal to 86 minus 80, which is 6. I divide both sides by 2, and I'll be left with x is just equal to 6 divided by 2, which is 3. So the answer for what's the population standard of the mean deviation, it has to be 3 here. All right, so again, we are using the same formula, x minus mu over standard deviation. Number 7. If the entire population mu is equal to 60, all right? All right, and if you didn't do number 7, go ahead and put the video on pause and see if you can figure out the answer now that you kind of watched a couple of these. While you're doing that, I'll set it up. All right, so the question is, if an entire population with mu equal to 60 and standard deviation is equal to 8, is transformed into z-scores. So if every single thing in the population is taken to a z-score, what does that mean? That means I'm going to take all the scores, convert them. When I convert all of them, the mean is automatically going to be equal to 0 if I'm looking in standard deviation. So this point here, when they talk about, you draw a vertical line, sorry. Like this point right here, straight down. Before I convert it, it's a 60. After I convert it, it's 60 minus 60 divided by 8 0 divided by 8 is going to be 0. So I already know, if we're looking here, that it'll have a mean of 0, right? So, and a standard deviation. The standard deviation here, in the raw scores, the standard deviation is 8, right? But whenever you are talking about in the z-scores, your standard deviations are going to be those numbers. You've standardized them. So it's going to be 1, 2, 3, the numbers that you find in the back of the book here. All right, your z-scores. So here, your standard deviation becomes 1. You can convert from the z to the raw scores. You can go from the raw scores back to the z, like what we're doing already. All right. Number 8, same thing. If you want to go ahead and work ahead of me, go ahead while I set this up. So I know my 1.5 is going to be equal to 6 divided by some number here, whatever my x happens to be. When I cross multiply, I find out that my x is going to be equal to 4. All right. The reason I don't even worry about this here, n equals 30, it doesn't even matter, right? For a sample of n equals 30, you don't even need that number because remember we're using the formula not to find the standard deviation n, right? We are actually using it to figure out what is our z-score. So using the formula again, z equals x minus mu over standard deviation, those are the numbers that you use. I was just trying to give you some extra info here. All right, number 9. And a sample with mean equal to 40. Right? Here in a sample of mu equal to 40. So my average is equal to 40. They tell me that my standard deviation is equal to 8. What is the corresponding z-score? So it's asking me to find the z, and it tells me my x is equal to 38. All right, go ahead and solve the problem if you can. If you notice here, right, I already know that the average is 40. And I know I scored less than 38. So in my head, I should automatically be thinking, like, that my z-score better be negative, right? So here I find out that my z is going to be equal to a negative. It's a negative in front of there, if you can kind of see it. Sorry. A negative 0.25. The answer here is going to be C. Number 10, the last one. For a sample with S equals 12, right? And it tells me that the score is 73. It's going to ask me, what is my mu? So I don't know this. What's my average? But I do know that when I scored a 73, I happen to be exactly 1 standard deviation below. So my number better be greater than 73. So go ahead and scratch out that 85 there. Okay. When I shove all of these in and just basically do the math, I find out that the average of the thing must have been an 85, right? So 85, x is going to be equal to 85. Oh, sorry, I did that in my head. Here, because I knew I was 1 standard deviation away, right? And so that means that my score is going to be equal to, my score of 73 is equal to the mean minus 1 times that 12 here, right? And technically. And that's how I ended up getting the 85. All right. All right, so if you have any questions about this, let me know, but you need to be very, very comfortable with using the tables in the back of the book because we're going on to the next section. And if you don't have the tables down cold, it's going to get very confusing. Thanks so much. If you have any questions, post to the discussion board or let me know.